This is Ruby. Today we're going to talk about variability, and in particular we're going to talk about the variance and the standard deviation. As you recall, variability can be measured with the standard deviation and the variance. In each case, when we measure variability with the standard deviation and variance, it's determined by measuring distance from the mean. If you look down at our 5-dog example, which we've used before, remember we have 5 dogs. We have a Rottweiler, we have a Greyhound, we have a Dachshund, we have a Terrier, and we have a French Bulldog. If we look at the Rottweiler, we see that in terms of height, the Rottweiler is taller than the average height of our dogs. The average height is measured and shown by the green line. We also see that the Greyhound is taller than the average height, but the poor little Dachshund, he's shorter than the average height, as is the French Bull Terrier. So what we're really interested in when we measure standard deviation is finding out all of the scores and how different they are from the mean. That is, what is the distance for each score from the mean? So what we're going to do is we're going to report the standard deviation, and we're going to do a computation for the standard deviation for a set of scores. The reason we're so interested in the standard deviation is because it is the most useful measurement of variability, because it provides a measure of the standard or average distance from the mean. To find the standard deviation, we must first compute the sum of the square deviations, and then we will compute the variance, and then finally we will compute the standard deviation. Alright, so what I've done here is I've given you a set of numbers, and we're assuming that this is a population. So the first thing we do is we start off with each of our scores. We have a score of 3, 1, 4, 3, 3, 4, and that's indicated under X. So the first thing we're going to do is we're going to sum the X's, and that's simply done by taking each score and adding it together. So we have 3 plus 1 plus 4 plus 3 plus 3 plus 4, which equals 18. So now we have the sum of X. The next thing we're going to do is we're going to compute the sum of the X squares, and that's simply, the direction there simply is to take the X and square it. So for the score of 3, we'd have 3 square, which is 9. For the score of 1, we have 1 square, which is 1. For the score of 4, we'd have 4 square, which is 16. For the score of 3, we have 3 square, which is 9. Another 3 square is 9, and another 4 square is 16. Then what we would do is we would take each of those X squares, and we're going to go ahead and sum those. So we're going to add them. So we're going to add together 9 plus 1 plus 16 plus 9 plus 9 plus 16, which equals 60. Now the third step is to compute the sum of the square deviations using the following equation. We have the sum of the X squares, and we're going to subtract the sum of X, note it's in parentheses, squared, divided by n. And remember, n is just the total number of scores. So what we're going to end up with is, in this equation, is 60. That's going to substitute for the sum of the X squares. Then 18, which is going to substitute for the sum of the X's. And remember, that's going to be squared. And it's going to be divided by 6, which is the total number of scores. So what we'll end up with is 324 divided by 6, which is 54. And we will simply subtract 54 from 60, and our answer for the sum of the square deviations will be 6. So that will then lead us to step 4, which is to compute the variance. And the variance is simply computed by taking the sum of squares and dividing it by the total number of scores. So in this case, the sum of squares is 6, and the total number of scores is 6, so we end up with 1. Then for step 5, we take the square root of the variance, and that will give us the standard deviation. So we're simply going to take the square root of 1, which is equal to 1. So that is our final answer, which is 1 for the standard deviation. Now, in the next slide, we're going to go ahead and we're going to use the computational formula, but this time we're going to assume that our scores came from a sample rather than a population. So what you'll notice here is step 1, step 2, and step 3 are identical to the problem that we just did. that in fact the sum of x is still equal to 18, the sum of the x squares is still equal to 60, and when we compute the sum of the squared deviations, we still have 6. So these first 3 steps are identical. What is different is step 4 and step 5. And what you'll notice is when we compute the variance, we now have the sums of squares, so we still have 6, but in the denominator, we're going to take n minus 1. So we're going to take the number of scores that we have, and we're going to subtract 1. So since we have 6 scores, we're going to subtract 1, we'll have 5. So now we have 6 divided by 5, which will give us 1.2. Then for step 5, we're going to take the standard deviation. So we're just going to take the square root of 1.2, which will give us 1.10. Now, you might ask the question, why is it that the sample problem, our standard deviation is larger, it's 1.10, than with our population problem, where our standard deviation was only 1? That is a good question to ask. The reason for that is that we make that correction in the denominator in step 4 and 5, where we have n minus 1. We make that correction because in general, we know that when we use a sample, we end up with a biased estimate. That's why we make that n minus 1 correction. Okay, that's it for today. Bye-bye.